All right, kids. Video two today. I'm very excited, and I'm hungry. Now I got the munchies. It's like late. I've been grading stuff. Now I've got the munchies, and I totally want that. Right? Don't you want that? Wow, that looks good, doesn't it? And I think some of these. Notice I said the Toblerone. I think I mentioned that Toblerone. By the way, it's an Italian word, I believe. And if you see an Italian word like that, you'd think it says Toblerone. Nah, in Italian, you see that N at that E at the end. You say it all. You say it all. Toblerone, right? I lived there for a little bit. I'll tell you guys about that sometime. When I was in architecture school, I lived in Italy for a fair amount of time. So at one point, I knew some decent Italian. Not anymore. It's been a while, but I do know how to say Toblerone. So this chocolate bar is awesome. I think, like I said, it's from Switzerland. If you look really closely, check out over here. I know you. I don't know if you can see my cursor, but in the mountain, this is, I think, the Matterhorn, and it's like a major famous mountain in Switzerland. And the Matterhorn, in that picture of the Matterhorn, it's a very important, or not important. It's a iconic. That's a good word. Iconic mountain for the Alps, which are in the middle of Europe. And if you look at that little in the thing, look, there's a little bear there. Do you see the bear? He's like dancing. There's his little face and his little ears. He's got little paws and little feet. Next time you're at the store with your parents, take them over there. Take your mom over there. Take your dad over there, and be like, "Hey, check this out." And you can show them the bear in the mountain. Do you see it? Do you see the bear? All right, I'm getting really close because I can see it if I look really close. But it's in that mountain. There's a little bear dancing in there. Anyway, this is our assignment today because I don't want to kill you with another 15-minute video. I want us, because now I got the munchies, I want us to figure out how to make a box for this awesome thing. So if I have the munchies, this would probably get me through. But you know what? If it's a real bad case, like I want like a lot of those candy bars. Like this is only one. I want all of them. Look at that. Oh, doesn't that look good? How many candy bars can I have there? How many candy triangular prisms can I eat in one night? Let's see how many are here. One. Let's count them. Let's count them. Count them. One, two, three, four, five, six, seven, eight, nine. Oh my gosh. Oh, that looks so good. Okay. So 9 of those giant candy bars, high quality Swiss chocolate, Switzerland chocolate right there. You know, it's got the little bear and the little mountain. Oh, what a cool thing, man. I want that. Okay, here's your assignment for today. Are you ready? You are going to make something for me that looks like this, but you're going to do it for this. Oh, not for that. You're going to do it for this. I want you to build me, design me the box that's going to fit this perfectly. Think you can do it? Now, a couple things I want to point out. This triangle, the one you see right here, all right, and I'm drawing it poorly, but this triangle, because they're all equilateral triangles, when you stack them all together, this is an equilateral triangle. Equilateral triangle. Equilateral. That means all sides equal. Lateral means the sides. Lateral means a quadrilateral. You guys know that. And equal, obviously. Wow, that's tricky. Equal meaning equal. All these are the same. So this is an equilateral triangle on the bases, right? So if we know that what our dimensions are going to be is like every one of these sides will be the same. So I'm going to give you the dimension for that. And we are going to say that the dimension for this, should we do centimeters or inches? What do you think? I'm thinking, I think we're going to do 9 centimeters here. Okay, we're going to say this is 9 centimeters. Okay, and when that means, if this is an equilateral triangle, that this also is 9 centimeters. And you know what else? Like, you know how crazy this is, the way it works? Equilateral triangle means that that's 9 centimeters. So what I want you to do is sketch this out, draw this out. You can use graph paper, or if you don't have graph paper, you can actually measure it out with a ruler and do your best. I want you to draw that out for me. Not 9 centimeters. Look at my fingers, right? I think 9 centimeters is about that big. So this is going to be a decent sized triangle, right? I want you to try to sketch that out, 9 centimeters. And now on a triangular prism, you're going to have that triangle, and you're also going to have the one that goes on this side, right? this triangle over here, and I'm trying to draw it like it's back here, this triangle will be the same. It will also be 9 centimeters by 9 centimeters by 9 centimeters, right? All three sides are the same. And then what connects those centimeters? Well, let's get into the color because we like different colors. Let's get my favorite blue. I'm going to come over here and say, wait a second, aren't these connected by rectangles? And I know it's in perspective, so you're like, wait, Mr. Pavson, that doesn't look like a perfect rectangle. And that's because it is a perfect rectangle, but not when it's drawn in or when it's taken a picture like this, you have perspective happening, which pushes it back. Now, what you need to know on this rectangle is, first of all, how long is the side? Well, actually, we already know that, don't we? Don't we already know this is 9 centimeters? Like, duh, it was over here, right? And that looks terrible, even though my writing's horrible there. I should fix that. 9 centimeters is the side of the rectangle, but what's the long edge of it, right? So we're going to kind of call this, let's call it 20. Yeah, I don't know if that's actually 20, but we're going to call it 20. Now, here's what I want you to do. I want you to draw a net of this box, this big box of Toblerones for me. And I'm going to draw one more line back here. I need to see one more line. This line is going to connect that side all the way to that corner right there. So now you see like the 3D shape we're drawing, right? And then that might be a little confusing, but basically, I want you to show me what this would look like as a net unfolded. And when I say a net unfolded, I mean like this. I want to see it like this on graph paper. If you have graph paper, make it so that every little, I'm sorry, I'm going back to the wrong one. Make it so that every square on the graph paper represents 1 centimeter, right? Now, I know that might not be true. The little boxes on the graph paper might actually be quite a bit smaller. They probably are. That's okay. We are just going to make that square represent 1 centimeter, right? Now, if you don't have graph paper, what do? Well, you can measure this out. You can scale it. You can kind of try to represent it. But now, what is your drawing going to look like? Well, you have to go back to your notion of what does a net for a triangular prism look like? And then you have to design it. Now, the other thing I want you to do, now this is the fun part. Give me an estimate of the areas of this shape. An estimate. The reason I say estimate is because the triangles, finding the area of the triangles, even though we know all the sides, finding the height of it is actually quite difficult. We don't know that. I didn't give that to you. So we might do that another day. So I'm not going to ask you to give me every part of the surface area. I want you to give me an estimate of it, meaning like know what the rectangles are. That's easy. Find the rectangles, right? And then give me an estimate of what you think each triangle is and say, okay, here's what I think we would do. Okay, so I want the net. I want it drawn at this scale. And I want you to do it on graph paper. If you don't have graph paper, I want you to measure it out, right? And then I want you to give me an estimate of our surface area. Remember, 3 rectangles on every triangular prism and 2 triangles. All right, you got it, kids? That's a lot of videos for today. Are you bored out of your minds? Probably. All right, have a great day. Do a good job on this. I will see you all on Wednesday. Bye, everybody.